My name is Guy Kemen, and I took the Advanced Composites Manufacturing course simply because of its title. So I am doing research on composites at Clemson University, and I've always been interested in composite materials. I've been riding and racing bicycles for a long time, and most high-end bicycle components are made from carbon fiber composites, and so that was really interesting to me. I wanted to know, how are these parts made, what are the manufacturing processes, what are the details of those processes. So that's why I was interested in the course. So the Advanced Composites Manufacturing Processes class is taught at ICAR, and it's part of the automotive engineering department, and I'm in mechanical engineering at Clemson on the main campus. But thankfully, we're allowed to take courses outside of our major. And when I saw the course description for this course for Advanced Composites Manufacturing Processes, I knew I wanted to take that. That was something that I really wanted to learn about. And so twice a week last semester, I took the bus most days from Clemson to ICAR to come in to learn about composites and plastics. We often say, oh, that's made out of carbon fiber, but that's a misnomer. So it's carbon fiber reinforced polymer, and a polymer is a type of plastic, right? It's a diluted plastic, and so in the course we learned about all different types of plastics and their chemistries and polymers and how these are made, and the different processes by which we make parts out of plastic, and then the overlap into composites. So reinforcing a fiber like carbon fiber or fiberglass, or even natural fibers like coconut or hemp, we reinforce those with a polymer, and all of a sudden we have a composite material. So depending on the application and the desired product, there are all sorts of different combinations that you can use to make a composite. In the Advanced Composites Manufacturing course, we did not only cover composite manufacturing processes, but we started off by studying plastics and their chemistry and polymers and their chemistry, and then we moved into manufacturing processes of plastics and polymers. So extrusion and injection molding and co-injection molding and overmolding and all these different types of processes that are used to make plastic parts. And from there we merged into composites, which a lot of the processes used to make plastic parts are also used for composites, but you have the added challenge of the fiber being in the plastic, in the polymer. So we covered then things like pultrusion and extrusion of fibers and how the fibers are made, and also resin transfer molding, manual layup processes, spray up processes, compression molding, and even more advanced things like automatic fiber placement, things that are really the cutting edge of composite manufacturing. So in the Advanced Composites Manufacturing course at ICAR, part of the course is a project where you're required to propose some sort of novel part that you're going to try to build out of a composite material or out of plastics. And so going back to why I wanted to take the course, which was because of my background with bicycles, I immediately thought, okay, what part can I build that I could use on my bicycle out of composites, out of carbon fiber? So I decided, well, I'm going to try to build a bicycle saddle, and it seemed to me like a reasonable goal to build in one semester to build a bicycle saddle out of carbon fiber. So to build my carbon fiber bicycle saddle, I first made a trial part using resin transfer molding, and then ended up going to just a manual layup process out of simplicity and budgetary constraints. So for the project, we have a $100 to $200 budget, and so to stay within this budget, I went to a manual layup process. So I had an open mold that I had 3D printed, and I soaked carbon fibers in epoxy resin, and then laid those wetted fibers into the mold, and then vacuum bagged that mold and allowed the carbon fiber and epoxy to cure. So the epoxy hardened, and then I had my part. Part of the saddle are rails underneath that are used to mount to the bicycle, and building those were probably the most challenging aspect, because the geometry is complex. And so what I ended up doing was 3D printing a core of the rails, and then covering those in carbon fiber, and using high compression tape, I conformed them to the 3D printed core and allowed that to harden. And so that's how I built those. The limited budget in the project meant that I couldn't go any type of traditional route of making a mold from aluminum or steel with a CNC machine. There was not time or money to do that, which is the traditional method. And I couldn't therefore use any type of high temperature molding processes, such as compression molding or pre-preg or autoclave molding. And so that forced me to think outside the box. And initially I 3D printed a prototype of the saddle shape itself, just to see what it would look like and to kind of think about the shape. And then I thought, well, why don't I just try 3D printing a negative mold and use that and cure it at room temperature. And that ended up working out pretty well to build a prototype saddle.
Process.
So I ended up building 5 saddle surfaces, and the first 3 were bad, and I had problems with voids in between the fibers, and just voids between the fibers and the surface in the mold, so the fibers didn't conform completely to the mold. And then I had problems with bubbles in the epoxy, and so to overcome those, I degassed the epoxy in the vacuum pot, and then I made sure that the fibers could move against each other, and when I put them in the mold, and made sure that they really were sitting in the mold correctly. So the lab portion of the course really allowed a deeper understanding of the processes that we were learning about in lecture. So sitting in lecture learning about injection molding or learning about resin transfer molding is interesting, but until you see it and do it, it doesn't stick. And so having the lab portion, I think, was great. It allowed me to understand the material better, and allowed me to have hands-on experience with these processes, so that when I go into industry and I see an injection molding machine, I'm familiar with it. It's something I've seen before and seen run before. So I think it was really helpful having the lab portion in addition to lecture. So because the project had a limited budget and also limited time frame, it required creative thinking on how to solve problems that I had as I started the design and construction of prototypes of my saddle. And I think that has a lot of similarities with any project in industry. So if you're working for a big company and they want you to design a new door panel for a car out of carbon fiber, you're not going to have unlimited time and unlimited money to do that. So being able to think creatively on how to solve problems that don't cost a lot of money, that save you time, is a skill that is invaluable in today's world. So I think having a project where you have a short deadline and you have a limited budget helps to grow that skill. So part of the course, and for the lab portion of the course, we did simulations using Moldex. So Moldex is a tool that allows you to simulate injection molding, and then for composite parts, resin transfer molding and compression molding. And so for my project during the initial stages, I did some resin transfer molding simulations to see what my part would look like if I used resin transfer molding to make it. And so that was cool. That was a software that I had never used before, and really you don't get to touch it all or even probably hear about during undergrad. So to use that during the course and for the project was a really great experience, and is something I can put on my resume now. So one of my dream careers would be to work as a design engineer in a bicycle company, designing bicycle components or bicycle frames. And this project and this course, I think, gives me a good stepping stone towards that, because now I have experience with carbon fiber production, carbon fiber part production, and I understand a lot of the different processes that are used, and I think I have a leg up now on other engineering students who are also cyclists or into bicycles that would want to work in that field. So I would love to be able to do something like that in the future.